or any load. We have only just spandrel and nothing. Yeah. This and that. This one. Every third one. The beams on this is something that's skeptical. Only difference is the beam. Two remaining beams framing into the gutter, but this only just beam framing to the column has less bending moment. Bending moment. Maybe it's one-way related. Maybe I'll kind of take a look at more quickly. This is one-way related load distribution. But I think that your question is here. So as an engineer, we like we want to use composite actions. This is the benefit of composite actions. With the benefit of composite action, we could reduce the steel section size. So I think at this point, those beams are pretty similar. I have to find out. Maybe only difference is this beam 18 by 35 framing into the column versus the other two framing into the gutter, but they are pretty in the same ranges. But you could see that the typical filler beam has a number of stud and camber, right? And the gutter, you reading it 24 by 55, but there is some they don't need camber here. So, but those are all the composite beams because we have a number of stud, right? So first of all, filler beam has a stud and camber. A Gauder don't need they chose the Gauder size, but they don't need camber. Just a number of studies are there. Um, if you somehow doesn't want to see, maybe you want to see uniform shear stud, maybe you could click here and give us the not pattern of the pattern of stud is that the ETABS can give us the uniform number of studs. It depends on the patterns. I think the composite actions calculation is slightly different. That's why this is 72 plus 4, right? So 76. So if we're using uniform shear start, uniform spacing, it requires more. But you can see this if you click it, and the number of studs, we as a structure engineer, we define number of studs, but typically these patterns are specified in some sort of typical detail. So when we call 100, I think depends on how the engineer set up the drawing. They have to follow that pattern of the spacing. But here, ETABS, they use provide a tool using pattern or and also just uniform spacing. So this pattern means 36 shear studs are located. I think we have to find out their assumption, but within some zone on each end, and middle zone is specified for shear studs. So I think this is something that we could just dig out and see how ETABS define that shear stud pattern. But but just generally, basically, you could read this, or the interior girder is 24 by 55, right? Or same number of girder studs. Spandrel beam, since you assign that group, you choose one 24 by 55 on spandrel beam on north south, and also spandrel beam on west south. It depends on, since you group it, I think you choose one sections. Uh, I explained that design criteria for spandrel beams more restricted. Still, this model has, spandrel beam. We also assign different load criteria, which is 38 inches, govern that size instead of L over 360. So I think still this one looks okay. So your question 18 by 35, I think I'm expecting the same size. Somehow 35 versus 40 is came out somehow ETABS chose based on a loading bending moment diagram. We'll see. I think I can just maybe create one simple model and see why ETABS chose calculate different bending moment diagram. And so next questions. Is info more CPU CNE? Okay, I think at this point, just generally, except this one slab nodes are off from that column. I think you could just zoom in and out and take a look at it. It's hard to find out because they are very closely located, but that's why you maybe just test and using all the deflection diagram. You could just animate it and see that all the nodes are connected. And check the bending moment diagram and shear force diagram. I think you could check it, whether all the numbers make sense or are consistent throughout all the floor. So I think overall this model is correct. The one thing, since we ran once, I said we have to analyze it. 18 members are consistent. You have to rerun it. Yeah, somehow there are two the beams on the south side also kind of weird. It choose a little big one step big size, but the um less number of shoe studs. So our typical beams 18 by 40 require 36 or 37 shoe stud, and this one you choose second step, or maybe because deflections. Uh, so this case we may have to regroup it so that you could choose the just one size for all these interior beams. So somehow, let me just read it. Oh, this still has a 6 members not. So let me rerun it and see it converge. Still we have a 21 here.
Professor, that's so the
Yes.
I already made the group for those beams. That's the one that you removed
Oh,
from
oh,
the design. So if you,
okay. So
yeah,
then let's, yeah, this one is not necessary to be, yeah, in the group. Then let me, okay, assign group. Okay, okay, I think it is right. And group. Now you could include this. So I just also, yeah, I'll just clear out only these two or four. It has a less tributary width. Uh, so I included only just the beams. Okay, without these four beams, they are all the same group. So let's see. So this, I think eventually what we have to do as an engineer, or no, now is F. It should choose